Hello friends, welcome to this fourth video on random process. This video will also explain you about the WSS process. We have already seen two problems priorly in the last videos on the WSS process. This will be one more to the addition of it. The problem is show that the process x of t where we have a cos lambda t plus b sin lambda t where a and b are random variables is going to be a WSS if the following conditions are satisfied. The conditions being E of A equal to E of B equal to 0, E of AB equal to 0 and E of A square is equal to E of B square. This problem is very much typical to the last discrete problem which we have done, only in the case that there explicitly the random variable took the values -1 and 2 with the probability. But over here they have given the value which we obtained using the data as direct conditions over here. So this problem becomes very easy compared to the last problem which we did. So we will quickly move on to solve the problem. So the prime target is to show that it is going to be a WSS. That is, it's a wide sense stationary process. So quickly recollecting that the conditions required to show that the process is WSS. What are they? The first condition is that I need to show that mean E of x of t is a constant. What is the second condition we need to prove? We need to prove that the autocorrelation, which is defined as expected value of x of t1 into x of t2, that is the product, is going to be a function of tau. What is tau? Tau is nothing but time 1 difference time 2. Okay, so difference meaning subtraction. So you subtract the bigger number from the smaller number, and what do you denote it as? You denote it as tau. So if these two conditions are satisfied, then I can claim that my given random process is going to be a WSS process. So we will quickly begin with our condition number 1. What is going to be condition number 1? I want expected value of x of t. So what is going to be expected value of x of t? Expected value of my x of t has been given over here as a cos lambda t plus b sin lambda t. We will have to observe that a and b have been described as the random variable. So what is the role of cos and sin which is over here? They are mere constants. We will quickly recollect the property of expectation that E of Ax is the same as A into E of x. The expectation will be effective only for the random variable and the constant will come outside. So when I apply the same thing, the constant will come outside. So cos lambda t giving you the expectation only for the random variable a. In the second term, similarly, the constant sin lambda t comes outside, leaving you with just expected value of b, which is the random variable. Now, look into our condition number 1. What we know about E of A and E of B, they have been provided as 0. So, this will become 0. This will become 0. So, the total value will become equal to 0. So, I have E of x of t is 0 and we know that 0 is a constant. So, what we have proved? We have proved that mean is a constant. The first condition has been proved now. Let us move on to prove the second condition. What is going to be the second condition? The second condition is that you need to show that the autocorrelation function R of T1, T2, which we define as expected value of x of T1 product x of T2 is going to be a function of tau, the time difference. What we have as x of t? X of t is a cos lambda t plus b sin lambda t. So this is what we have in our question. Now what we want is x of t1. How to get x of t1? Wherever have t, replace it with t1. So this becomes a cos lambda t1 plus b sin lambda t1. What is the second term? It is x of t2. What will be x of t2? Wherever you have t, replace it with t2. So this becomes a cos lambda t2 plus b sin lambda t2. Now put everything over there in the expectation. So we have this as expected value of A cos x of t1 is lambda t1 plus B sine lambda t1. Product. What is the second term x of t2? Substitute this. A cos lambda t2 plus B sine lambda t2. So now we have two terms in the first value and two terms in the second value. When I take the product of it, totally we will be arriving at four terms. So let me expand and get the four terms. So it is expected value of the first term A into A is A square cos lambda t1 cos lambda t2. Second term A into B. So you have expected value of A, B cos lambda t1 sine lambda t2. So the third term B into A. So this gives me expected value of BA sine lambda t1 cos lambda t2 plus the next term gives me expected value of B into B makes it as B square sine lambda t1 sine lambda t2. So totally on expansion I have four terms. Again we need to keep in mind which is our random variable. The random variables are just my A and B. So what is the role of cos, sine and cos A, sine and sine and sine? All these terms are going to be treated like your constant. So what will happen to the constant? The constants will come outside the expectation. So what will happen in our next stages? We will have the quantity to be equal to, which will come outside over here. Your cos lambda t1, cos lambda t2 comes outside. Cos lambda t1, cos lambda t2 comes outside, leaving you with expectation of a square. So expectation of a square alone will be there. What will come outside? Cos lambda t1 sin lambda t2 plus cos lambda t1 sin lambda t2 comes outside, leaving you with E of, what was there inside? It is the random variable AB. So we have E of AB. What is the third term? What comes outside over here? Sin lambda t1 cos lambda t2. Sin lambda t1 cos lambda t2. What is inside the expectation? Inside the expectation, I have BA. This can also be written as AB since it is going to be a mere product. The last term which we have sin lambda t1 sin lambda t2. So sin lambda t1 sin lambda t2 comes outside, leaving you with expectation of b square. So we have arrived at this stage. Now let us get back to the conditions given to us. What has been given as expected value of AB? Expected value of AB has been defined as 0. So go and apply this over here. So what happens to this expected value of AB over here? This will now turn out as 0. Now what happens to this expected value of AB over here? This will now turn out as 0. So what will be left out now? The left out quantity will be cos lambda t1, cos lambda t2 with E of A square, and the next value will be plus sin lambda t1 sin lambda t2 into E of B square. Now again go back to your original conditions. What is the third condition given to us? E of A square and E of B square are the same. Let me treat them to be some value called as k. So E of A square is k, E of B square is also k. Say. So what will happen over here? I assume that E of A square is k. I assume E of B square also to be equal to k. So when I take k common outside, I will be left out with cos lambda t1, cos lambda t2 plus sin lambda t1, sin lambda t2. Now, quickly recollect the trigonometric identity which we have learnt in our lower grades. So, this gets identically to match with cos A, cos B plus sine A, sine B, which gives the identity as cos A minus B. So what will happen to my quantity now? This will become cos of what is in place of A? I have lambda T1 minus what is in place of B? I have it as lambda T2. So I have K cos lambda into T1 minus T2. How can I write T1 minus T2 as? I can write it as K cos lambda times tau. So what I have arrived finally at a function of tau. So I have proved that the autocorrelation function gives me finally a function of tau. Hence, the two conditions for WSS, namely mean is a constant and autocorrelation function is a function of tau, has been proved in our case. Hence, we prove that the given process x of t, which has been defined over here as a cos lambda t plus b sin lambda t, is going to be a WSS process. That's it, children. It's very easy. Just do it step by step, taking one at a time. Thank you.